Okay, question 24 is our circle theorems question, and it's a bit of an unusual type of question in the sense that rather than working out certain angles, we're asked to recall our circle theorem facts that we need to learn. So we're told that A, B, C and D are points on a circle. Now hopefully you're recognizing that because they are all points that are sitting on the circumference of the circle, this is known as a cyclic quadrilateral. And we're told that angle ABC is 92, ACB, so ACB is 38, ACD, that's 50, and CDE, yeah, this one here is 32. So we're asked to tick whether or not the statement they say is correct and give a reason. So this bit here, just on its own, will give you nothing. It's the reason that gives you the mark. But obviously if you tick the wrong box but give the correct reason, you would lose the mark. So you need to make sure you're careful with this. So it's saying that AC is the diameter. Now it looks like the diameter to me, but it's not drawn accurately. So we can't just say, oh yeah, it's the diameter. So what we need to learn, or what we need to know, is the fact that if it was the diameter, then an angle that is formed from the diameter, so if we look at, say, this 92 degree here, it's formed by sitting on this line, and we say that the angle is subtended from this line, it should always equal 90 degrees. Okay, so if it were the diameter, it should equal 90 degrees. Now we can see it's actually 92, so therefore it cannot be the diameter. So we say, give the reason, angle subtended from the diameter equals 90 degrees, not 92. So something like that would give you the mark. The second statement, so each statement's worth 1 mark. There's 4 statements here. Angle ADC equals 88. So let's have a look at that one. ADC, they're saying that this one should equal 88. So what we should know is that opposite angles in a cyclic quadrilateral, they add up to 180. So this one is true, and the reason is just what I've said. So opposite angles in a cyclic quadrilateral add to 180 degrees. Okay. The next statement, ABCD is a trapezium. Now, ABCD doesn't really look like a trapezium, but again, it's not drawn accurately. So a trapezium, different ways of drawing a trapezium, but essentially, you've got one pair that's parallel, four-sided shape, where one pair is parallel and the other pair aren't parallel. Okay, so if they are, if it is a trapezium, then we need to prove that there's only one pair that's parallel and the other pair that's not. So if we think about our rules for parallel lines, we should know that co-interior angles add up to 180. Okay, so if we think about a possible set of parallel lines, let's think about maybe this pair here. So if these two lines were parallel, then I can form a C shape, or a backward C shape here, and that C shape helps me identify a pair of co-interior angles. So this angle here and these angles, they should add to 180. Okay, so if they do, then that means that those lines are parallel, because otherwise that rule wouldn't work. So 92 add 38 add 50 is 180. Okay, so therefore these lines are parallel. Okay, so it could be a trapezium, but I'm not 100% sure, because what I need to prove now is that it doesn't work the other way round, because if it works the other way round, if they add up to 180 again, then I know that they are all parallel. Okay, so you know, it won't be a trapezium. So let's have a look at this one. Wow, it's not very good. So looking at these two lines, they don't look parallel anyway, but do these add up to 180? Well, probably not, considering there's two 8s. Let's see what it adds up to. 88 add 38 add 50. It only gives me 176. Okay, so the fact is that these lines are not parallel, these lines are parallel, and therefore it is a trapezium. So we need to find a way of explaining this. I'm going to say that AB and CD, which were these two lines, AB and CD, are parallel, since angle ABC and angle BCD, which, remember, were these two angles, ABC and BCD, add up to 180. And then I'm going to say that the other two pairs of lines, so that is this pair BC and AD, are not parallel, since angle, and I want to talk about these two angles, so angle ADC and this angle here, so that's BCD, do not add to 180 degrees. Okay, so quite a lot of explanation there, but this is a good explanation to explain why it's a trapezium. The last one, DE, so that's this line here, is a tangent to the circle. So a tangent is a line that just touches our circle, and if we have a look at the angle CAD, so this angle here, if it is a tangent, then because of alternate segment theorem, these two angles should be the same. Okay, so alternate segment theorem says that the angle formed outside the circle to the tangent, sorry, the angle formed on this segment here will equal the angle in the opposite segment. So if we have a look here, does this work? Well, looking at, we've got two angles here, and we're trying to find this angle here. So using 180 minus the 92 and 38 tells me that this angle here is 50. And because it's a quadrilateral, I know that it has to add up to 360. So 360 minus the 50, which I know is right, minus the 92, which I know is right, minus the 38 and the 50, minus the 88, which I know is right, means that this leftover angle is actually 42. So because it doesn't equal 32, then it cannot be a tangent. So I'm going to say it's not. So I'm going to just say that angle CAD, which was this one here, CAD, equals 42 degrees, not 32 degrees as stated by the alternate segment theorem.